All right, we're going to be looking at the fundamental theorem of calculus, and there's two parts to it. So the first part is if a function is continuous on a to b, then we can say that g of x is the integral from a to x of f of t dt is continuous on that same interval a to b and differentiable on a to b. And also that the derivative of g is f of x. Okay? Or we can see it like this. So, all right, the derivative of the integral is just the function, right? So really part one says if we define a function as the definite integral of another function, then the new function is an antiderivative of f. So given that f represents the rate at which the function f of x, big F of x, is changing, that is f of x is the derivative of the antiderivative, then we know that the integral from a to b of f of x dx represents the total change, or that net change, in big F on the interval a to b. Right? So that's a lot to process. Let's look at part 2, and then we'll get through some examples. Might be the best way to look at these. So part 2 is if a function f is continuous on a closed interval a to b, and f of x is an antiderivative of f on the interval a to b, then the integral from a to b of f of x dx is big F of b minus big F of a. So the definite integral of a function over a to b is equal to the net change, or the displacement, in the antiderivative of f on the same interval. So basically, big idea is this thing right here, this notation. So we have the integral. Thought I was drawing. We have the integral, right? We can find the antiderivative, but then we evaluate it from a to b. So that's what that line there is. That says evaluate it on those bounds. And evaluating it means that function that we find here, we'll substitute in b, and then we'll subtract off substituting in a. All right? So let's do some. So find the value of the definite integral. So all right, I have the integral from 1 to 2 of x squared minus 3 dx. So we can use our integral properties, right? Remember, we would add 1 to the power and divide by the new power. So this becomes x cubed over 3 minus 3x. And then normally, right, we would put plus c. But we have bounds we want to evaluate with. So we're going to evaluate it. So I put a bar there from 1 to 2. So then here's what I do. I plug in 2. So that's 2 cubed over 3 minus 3 times 2. And then I want to subtract off if I substitute in 1. I throw a big bracket over it so that I don't lose that minus, that whole thing. So 1 cubed over 3 minus 3 times 1. And then I do the math. So 2 cubed is 8. So 8 thirds. And then minus 6. I'm going to make that 18 thirds, right? Just so we're in a common denominator. And then I do some little side work here, and that's 1/3 minus 3. So what is that, 9 thirds? So then 1/3 minus 9 thirds is a negative 8 thirds. But remember, I'm subtracting that over. So really it's plus 8 thirds. And then I can evaluate this, right? So 8 minus 18 is negative 10. And then negative 10 plus 8 is negative 2. So our area is going to be negative 2 thirds. All right, we're going to do the same thing over here. I'm going to make that 3x to the 1/2. So when I do the integral, that's going to be 3x to the 3/2. And then I'm dividing by 3/2, which is the same as multiplying by 2 thirds. And then I'll be evaluating from 1 to 4. And what I'll do here is those 3's will cancel out. So really it's 2x to the 3/2 evaluated from 1 to 4. So I have 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. So 4 to the 3/2, you can do the square root first and say, hey, the square root of 4 is 2, 2 cubed is 8, 8 times 2 is 16. And then that's going to be 1, 1 times 2 is 2, and 16 minus 2 is 14. Okay. Do some more here. I have to use one of our techniques here because we don't know substitution just yet. That's a future lesson that is coming up. So I have to multiply that out. So I have to do 2x minus 1 times 2x minus 1. And that's going to give me 4x squared. And then I'll have minus 2x minus 2x, so minus 4x. And then negative 1 times negative 1 is positive 1. Right? Now I can do the integral. So I have 4x cubed over 3 minus 4x squared over 2. And then plus x. And then I'm going to evaluate it from negative 1 to 1. And let's substitute in. I'll simplify as I go along. So 1 cubed minus this becomes 2. 2 times x squared plus x minus, if I substitute in negative 1, oh, that's 2. All right, let's see what we get here. We get 4 thirds. Oh my gosh. Minus 2, so that's going to be 6 thirds. And then plus 1, so that'll be 3 thirds. And then I'll subtract off a big quantity here. Let's see, that's going to be negative 4 thirds minus 2 minus 1. And then here's what I'm going to do. Go ahead and distribute that negative. All of these are negative, which means they'll switch to positive. And then let's see what we get. So 4 minus 6 is negative 2. Negative 2 plus 3 is 1. 1 and 4 is 5. 5 and 6 is 11. And 11 and 3 is 14. So 14 thirds. All right. Oh, we got a trig function in here. Alrighty. So this is going to give us negative cosine of x and then plus x evaluated from 0 to pi. So I get negative cosine of pi plus pi minus, if I substitute in 0, so negative cosine of 0 plus 0. So let's see, cosine of pi is negative 1. Negative cosine of pi is going to be positive 1, so I have 1 plus pi. Cosine of 0 is 1, so negative cosine is negative 1, and then plus 0. But really I have negative and a negative, so that's plus 1. And then 1 plus 1 is 2, so 2 plus pi, or pi plus 2. We got a lot going on with this one. All right, let's make this integral from 1 to 8. Let's make that square root of 2 and times x to the negative 1/2. Make things a little easier. All right, so square root of 2 is a multiplier I can pull out, so square root of 2. And then I can add 1 to the power and divide by the new power. So if I add 1, I get 1/2. So that's x to the 1/2. And then dividing by 1/2 is the same as multiplying by 2. And then I'm going to evaluate that from 1 to 8. All right. So I can really pull the 2 out even further, right? So I'll make that 2 root 2. And then times the square root of x evaluated from 1 to 8. So that's going to be the square root of 8 minus the square root of 1, right? And then I can redistribute. So 2 root 2 times 8 is really 2 times square root of 16. Square root of 16 is 4. 2 times 4 is 8. And then 2 root 2 times negative square root of 1 is just negative 1, right? So minus 2 root 2. And there we have it, 8 minus 2 root 2. All right, this one here might want to simplify. So we're looking at integral from 1 to 4, and we'll make that x to the 1/2, and then we'll use exponent rules to simplify. So 1 minus 1/2 is 1/2, and then there's nothing to combine there, so we'll just make that 2 times x to the negative 1/2. Then we can evaluate that. So add 1 to the power, it's going to make it 3 over 2, which means we have to multiply by 2/3. And then I have minus 2 is a multiplier I could pull out. If I add 1, I get 1/2. But then dividing by negative 1/2 is really like multiplying by negative 2, right? Oh, and I don't know why I have negative, because I was a positive 1/2. And then we're going to evaluate that from 1 to 4. So we have 2/3, and then 4 to the 3/2, minus 4 times 4 to the 1/2, minus if I substitute in 1. So 2/3, 1 to the 3/2, minus 4 times 1 to the 1/2. And then we'll do some math again here. So square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16, so 16/3. 4 to the 1/2 is 2, so minus 8, which will make that 24/3. And then do some side math here. So that's going to be 2/3 and then minus 4. So let's make that 12. So let's see, 2 minus 12 is negative 10/3. But I'm subtracting that whole quantity off. So really we will add 10/3. So then 16 minus 24 is negative 8. Negative 8 plus 10 is 2. So we get 2/3. All right, now here's a general form for that part 1. Right, so let's say we have a function we're substituting in. So no longer like 1 to 2, right? Let's say we have 1 to x squared, right? So we can still do what we're used to doing, right? We just have to add in an additional piece. So we can do that composition. So instead of f of t dt, we'll evaluate it, right? And we'll get f of whatever that function is. So if I'm doing x squared, f of x squared, but I have to incorporate the derivative of that function. So I'd have to multiply that by 2x. Right? And the same works as if both bounds are functions. We just have to account for both of those derivatives of those functions. So we'll just do one example here, right? So find the derivative if our function is this integral, right? So normally the derivative of the antiderivative is just going to be this piece, right? So it's just going to be e to the t squared. And then we're going to evaluate that from 0 to x squared, which is just like substituting it in. Then we also have to multiply it by that derivative here, so 2x, right? So we can substitute in that x squared, so that'd be e x to the 4th, right? And then I would subtract off e to the 0 squared, right? And then I'm multiplying it by that derivative of that top function, so 2x. So I'm left with 2x e to the x to the 4th. So that's kind of like a mouthful there, but that is how that works. All right, and that is all for this section. It's kind of a shorter video here. So if you have any questions, let me know.